Hi there, and welcome to presentation number 3 of Module 3 of Laser Classrooms Bringing STEM to Light. In this presentation, we are going to take a look at exploring and elaborating on the color that we learned in our last module. So what we know so far is that, of course, we see by having light come from a source and bounce off of objects and into our eyes. We know that white light contains all the colors of the rainbow, and that we can add colors of light together to produce new colors of light, including white light. And we know that objects appear as the color of light that they reflect back to our eyes. All the other colors that we don't see in a particular object are absorbed by that object. So how might we take what we know so far about color and light and apply it to a novel situation? Well, we're going to have fun with some M&Ms and a green light. If you were sitting in a room with nothing but green light and you tried to sort a bag of M&Ms, what do you think would happen? How easy do you think it would be? Do you think you'd be able to get it right? What percent accuracy do you think you'd get? I challenge you. This is how you do it. Grab a bag of M&Ms, 3 light blocks, or a green, a red, and a blue LED. Something white to pour out the M&Ms onto, like either I have a piece of paper here. You can use a white paper plate also. So the first thing we're going to do is to create some fun data sheets here, and we're going to see how many of each color of M&M we're going to be starting with. You can choose whatever kind of M&Ms, and if you're worried about kids eating the candy, then use pom-poms or something. And it doesn't matter what colors are in the bag as long as you have red, green, and blue present, because those are the colors that are going to be, that we're really going to spend some time trying to figure out and trying to see and trying to count. I'm going to take you through the basic procedure of this and then leave it up to you as to exactly how you want to use it or implement it, how many different colors you want to have them search for and so forth. So I'm going to give you the basic idea here. So you start by doing this, counting out. So we have 17 blue ones, we have 12 red, 6 brown, 3 green, 8 yellow, and 11 orange. And we're going to see if we put these same M&Ms, this is all the M&Ms that you just saw on the last page. This is looking at them under the green light. Now I can pick out the ones that are probably yellow and the ones that are probably blue when I'm using the green light here. But the rest of them, I can tell there are some differences, but I really can't tell. So this is going to be a little bit of a frustrating experience, but we want kids to actually go ahead and take a blank template with a circle for each color and give them a limited amount of time, maybe 2 to 3 minutes, depending on their age, 3 to 5 maybe, to see how many M&Ms they can sort into the right circles. Now they know how many they're supposed to have, so that's a bit of a clue. Some of them will use that and other ones will not. The important thing during this is that the green source of light really be the only source of light. So you really do need a pretty dark room. And I'm doing this in a closet with the door shut and using 1 green light box. So that 1 light box generates plenty of light to be able to do this. And we want them to record how many, so after they've sorted, then you'll turn the light back on and we'll see how they did. How many M&Ms were in the wrong circle? How many M&Ms were in the right circle? And you can repeat it with the red and the blue lights. A fun variation of this is to actually give them 2, not all 3, but 2 lights and see if they have any better luck. What do you think? Sometimes they have better luck with 2 lights. And of course, if you give them all 3, that's going to be the solution, right? Then they can use the white light, but it would still be a task. So we're elaborating here. We're going to ask, which color yielded the best results? Which color light yielded the worst results? Which color M&Ms were hardest to find? And why? Why? Why could you use the 3 light blocks together to get better results? So that why, why was it easier to find maybe yellow than it was to find, blue or green or red? Why is it easier to find some colors than others? Well, it all has to do with, of course, what we learned in the last lesson. We can see the color as the result of the wavelength of light that is reflected off of something and back into our eyes. If all we have is a green light, there's only green to be reflected back. And if the M&M is not green, it's going to absorb the green and not have much to reflect back. Now, those light M&Ms that you could actually see, as you know, pigment colors are not pure. We're not only dealing with straight yellow or straight blue or straight red. So some light does get reflected back to us. There is some green, obviously, in that yellow, or there is some green in that blue that's able to get reflected back to us, but not enough so that we can really see the color clearly. But when you have only a green light and a red M&M, a red M&M is going to absorb pretty much all of that red light. Now, not all of it altogether, otherwise we wouldn't be able to see anything at all, right? I mean, there is obviously some light reflecting back to us. Or what we're seeing really is the contrast between the white paper and the darkness of the M&M, which is absorbing the light, which is kind of the opposite of what we usually think of. We usually think we can see things because it's reflecting light back. Well, we're actually seeing the dark M&M because it's in contrast to the white that's reflecting the green back. If you were to have a black piece of paper under there, this would be even more difficult because it would be hard to see the M&Ms at all. You wouldn't have a contrast for them. So that is an elaborate activity. We kind of took their conceptual understandings and we put them to the test. We challenged it and asked them to develop a deeper and broader understanding of what we explained to them in the previous section. And they got to use and apply and hopefully reinforce that new knowledge. And you can structure additional questions and additional inquiries to encourage them to probe and make some more reasonable judgments using new information. And that's it for this activity. Thank you, and I'll see you in the next one.